Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorising the difference of two squares. So we are factorising. Remember, that's the opposite of expanding. So what I'm going to do is I'm going to expand this expression, and then we're just going to factorise by doing the opposite. So if I expand this using FOIL, method that we learnt previously, well, firsts a times a, O outsides is a times negative b, insides is a times positive b, and last, the thing that occurs last in each bracket, b times negative b is negative b squared. So these two terms cancel out. Negative AB plus AB is 0. So if I expand A plus B and A minus B, I'm just left with A squared minus B squared. So what does this have to do with factorising? Well, if I expand this, I get this. So that means if I factorise a squared minus b squared, it's just this here. This gives us a quick way to factorise the difference of two squares. When you have a perfect square minus a perfect square, it's got to be a minus because that's what difference means. So perfect square minus a perfect square, you factorise it, you square root the first and put it in each bracket. You square root the second, put it in each bracket. One bracket gets a plus, one gets a minus, and you're done. So here we're factorising expressions that look like this, that are the difference of two squares, and our answer will look like this. Probably sounds a bit complicated, so let's do a few examples. So let's say I want to factorise x squared minus 4. Well, you do this nice and simply. You get two brackets up. You square root the first, so square root of x squared is just x, so I'll put that in each bracket. The square root of 4 is just 2, so I'll put a 2 in each bracket. So then one bracket gets a minus, one gets a plus. It doesn't matter which way around you put the minus and the plus, because it turns out we are multiplying these brackets, and the order in which you multiply things doesn't matter. So if I were to expand this using FOIL, I would get this. We've factorised this expression. We've written it as something times something, and we're done. Let's do x squared minus 81. Once again, it's a perfect square minus a perfect square. Remember, difference means minus. So here's how we do it. Set up two brackets, square root the first, square root the second, square root of 81 is 9. One bracket gets a plus, one gets a minus, and we're done. If I were to expand this, I'd get that. So what about this one here, 4x squared minus 49? Well, this one may look different, may look tougher, but we're going to do it in the same way. 4 is a perfect square, x squared is a perfect square, and 49 is a perfect square. So this is a perfect square minus a perfect square. 4x squared minus 49, difference of two squares. So we're going to do it the same way. We get two brackets. Square root the first. So the square root of 4 is 2. Square root of x squared is x. So the square root of 4x squared is just 2x. Now I square root 49. Put it in each bracket. One gets a minus, one gets a plus. Once again, if you expand this using FOIL, you get that. So we're going to do this one just like we did our previous example, 9x squared minus 1. So 9x squared is a perfect square, 1 is a perfect square. Square root of 9x squared is 3x, because 3x times 3x is 9x squared. Square root of 1 is just 1. One bracket gets a plus, one bracket gets a minus, and we're done. So let's look at this one here. We have 2x squared minus 18. Problem is 2 and 18 are not perfect squares. There's no whole number you can multiply by itself to get to 2 or to get to 18. Remember, the perfect squares like 1, 4, 9, 16, 25, 36. These are not perfect squares. So how are we going to do this? Well, it turns out though, unlike in the previous four examples, these two terms, 2x squared and 18, have a common factor. We're going to use the highest common factor method that we used in the previous lesson. The highest common factor of 2x squared and 18 is 2. So whenever each term has a common factor, take it out first. Here, 9x squared minus 1, 4x squared minus 49, there were no common factors, so we couldn't use this trick. But here, 2x squared and 18 do have a common factor. So what do I times by 2 to get to 2x squared? Well, that's x squared. What do I times by 2 to get to negative 18? Well, that's negative 9. So what you can see now that we've taken out the 2, we do have the difference of two squares. X squared minus 9, perfect square minus a perfect square. So I can factorize this part using the difference of two squares. So I still have my 2, that hasn't gone anywhere. So if I'm going to factorize x squared minus 9, square root the first, square root the second, one bracket gets a plus, one gets a minus, and then we're done. All right, what about 2x cubed minus 2x? So this one again is tricky. It's not the difference of two squares. 2 is not a perfect square. X cubed is not a perfect square. So how am I going to do this? Well, I know that each term has a common factor, so I should always take out a common factor if there is one. So these two terms have a common factor of 2x. They both have a 2, they both have an x. So what do I multiply by 2x to get 2x cubed? Well, lucky from doing index laws, you know that that's x squared. You need to multiply x by x squared to get x cubed. What do I multiply by 2x to get negative 2x? Well, that's just negative 1. So once again, after taking out the common factor, we have difference of two squares. We will leave the 2x alone. So let's factorize x squared minus 1. So the square root of x squared is x. The square root of 1 is just 1. One bracket gets a minus, one gets a plus, and we're done. If you expand this using FOIL, you will get this answer. So I just want to make this point again, difference of two squares. It has to be the difference. This method only works when it's a perfect square minus a perfect square. If you have something like x squared plus 1, you actually can't factorize that. We can't factorize this. This is not the difference of two squares, it's the sum of two squares. Plus means sum. So you can only use this method when it's the difference, when it is a perfect square minus another perfect square. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.